Okay, so it looks like today our thing is week 8. And let's see. So the first question is, what is a vector? Really? So what a vector is, it's, if you Google it, basically, it's going to say a quantity having direction as well as magnitude, especially as determining the position of one point in space relative to another. And I guess in our need, it would be basically think of an arrow just going out infinitely in one direction at a certain magnitude that's consistent. So just be arrow, boom, x, y axis, going straight out to an area. And the direction is, which direction is it going? Is it going positive, negative, yada, yada. And its magnitude would be its y. So is it going positive magnitude, negative magnitude, and at what magnitude? So how much of a y is it increasing with each x it's going over?
This is the distance.
Yeah,
right?
Pretty much. So what is a polar coordinate? It looks kind of like what a polar coordinate is. It's basically, so if here's your, it's kind of like an angle. So if here was your x and y, out here would be one point. And wherever that point is, that would be your polar coordinate telling you, oh, what is this angle at this certain coordinate? Seems to be the easiest way to describe it.
Yeah.
I have no idea what a Cartesian is.
Polar coordinate is oh, corn animal. Where's the information for the extra?
And it seems like a Cartesian is kind of the same idea as a polar, but instead of it being with your degrees or kind of with what it looks like in a polar coordinate. It looked a lot more like, one second. Okay, yeah, so here's a good definition. So Cartesian is kind of like, here's the point, this is how far along and how far up it is. So how much x, how much y.
That's what it is, okay.
Polar coordinate is how far away and at what angle.
Okay.
So it'd be kind of like in that last homework problem that we had yesterday with like the wire coming off the roof, off that antenna. That seems like it would definitely be more of a Cartesian or a polar coordinate where it's this long at this angle would be your wire that you have to put in. And to convert between them, you have to use a triangle. So you'd use a right triangle, and to convert between them, you would have the your Cartesian would be related to your x and your y, while your polar would be equal to the slope of that triangle there. So if you're converting between them, you just basically say, so here's this one that's 12 and 5 for polar coordinates, which would be your bottom of your triangle, and then your y of your triangle here. Converting that to polar coordinates would just be solving for r. What's this other side over here? And that would give you your polar coordinates.
Okay.
I think that's all that we have to do today. And we've been talking more or less about that, or at least really similar stuff to that. For a long time, like the law of sines and cosines and everything.
Mm-hmm.
So does anybody have any questions on this at all?
I don't think so.
No.
This week is just vectors and something else that we had for homework. I didn't see. It was vectors and something else, and then just an exam, right?
Yeah. So it's vectors, and let's see, vectors. What's it say? If it overloads, why is the internet slow and can't work? And so that should be vectors. Then the second part of the week will be solving more triangles.
Okay.
Same thing.
I like triangles.
Yeah, as soon as you figure out your
Yeah.
formulas, it becomes just plugging in and going.
That's pretty much how
Right.
triangles are. Pretty easy.
Okay. Well, I'll post this then, and we'll meet again on 7-ish on Thursday.
Yeah.
Yep.
All right. See you guys.
Good. See ya.